Welcome to session 22, Solving Quadratics. Today, you will choose efficiently among factoring, square roots, completing the square, and the formula. Use the discriminant to predict real solutions, and verify quadratic roots algebraically and graphically. Watch the structure, not just the arithmetic, because each move must preserve the meaning of the problem. The visual gives us the central idea. Each panel connects an algebraic sign to visible geometry. A positive discriminant produces two distinct x-intercepts. 0 produces one repeated root at tangency, and a negative discriminant keeps the graph away from the x-axis in the real plane. Use this first move. Put the equation in standard form and identify sign values of a, b, c. Then, factor when integer factors are visible. Use square roots when a square is isolated. Worked example, square root property. Solve x3 squared equals 16. Step 1. Take both square root branches. x3 equals plus or minus 4. Step 2. Add 3. X equals 7 or x equals minus 1. Step 3. Both make the squared quantity equal 16. The final answer is x equals 7 minus 1. Check that it satisfies the original conditions and carries the correct units. Now it is your turn. Solve x squared for x12 equals 0. Pause, write each algebra step, and use the next 6 seconds to finish your solution. Here is the modeled solution. The answer is x equals 6 minus 2. Factor using numbers whose product is minus 12 and sum is minus 4. Verify it against the exact wording before moving on. Session 22 recap. Put the equation in standard form and identify sign values of a, b, c. Next, factor when integer factors are visible. Use square roots when a square is isolated. Then, use completing the square to expose vertex structure or the formula for a universal method. Finally, check each root and compare the solution count with the discriminant. A complete solution shows the reasoning, checks the result, and states what the answer means.